Hello students, this is Ashani from Cheenta.com. In this video, we will talk about a very beautiful concept from Olympiad geometry. We will look at the concept known as harmonic conjugates, and then we will see a very interesting application of it using Shiva's theorem and Menelaus theorem. Don't worry if you are not aware of these theorems. I will tell you exactly what they are, and I hope that you will learn something interesting from this video. Let's start with the harmonic conjugates. Suppose we have a straight line like this, and we have a point A and a point B on this particular straight line. We will say that AB and CD are harmonic conjugates if something happens. So let's pick up two more points, C and D. When is C and D harmonic conjugate with respect to A and B? When does it happen? Well, the condition is really simple. Whatever ratio C divides AB internally, in that same ratio, D should divide AB externally. I'll write down what this precisely means. AC over CB, that will be some number, some ratio, right? Maybe by looking at this picture, AC is 3 parts and CB is 1 part. This is just a guess, an eye estimation. Now it's possible that AD over DB is also 3:1. That's possible. Maybe. There is a slight change that you have to do. You have to also consider for the direction. So if you think that this direction is positive, then when you calculate dB, then you're going from right to left, you have to take the negative sign. So the condition is now clear. AC over CB is equal to negative of AD over DB. If this happens, then we say that C and D are harmonic conjugates with respect to A and B. Here is a little challenging question. It's a challenge. If C is the midpoint, C is the midpoint of AB, where is the point D? What is the location of the point D? Can you tell me that? Where is D? In fact, you can do a mental experiment. Imagine that C is moving, sliding toward the midpoint of AB. That's called the midpoint O. C is slowly moving toward the midpoint of AB. What will happen to the point D? How will it move and toward which direction will it travel? Think about it and maybe you can put it in the comment section. Now, let's look at a very beautiful application of this idea of harmonic conjugates. There are two very important theorems in geometry. One is known as the Shiva's theorem, and the other one is called the Menelaus theorem. A lot of Olympiad problems are actually built on these. What is the Shiva's theorem? The Shiva's theorem says that if you have a triangle, let's say A, B, and C, And if you have 3 lines, AK, BQ, and CP. Suppose I have 3 lines like this. And I join. Okay, so let's start with Shiva's theorem. It says that BK over KC times CQ over QA times AP over PB is 1. That's the statement of the Shiva's theorem. The proof involves an argument using areas of triangles. It's a very beautiful argument. We have a separate video on Shiva's theorem in this channel. You can watch it. Similarly, Menelaus theorem is about collinear points. This one was about concurrent lines. Menelaus theorem is about collinear points. So let me draw the Menelaus theorem, or draw the picture of it. Again, suppose we have A, B, C, and we have 3 points. Let's say, I'll just name it similarly, Q, P, and K prime. We have 3 points which are collinear. Then what the Menelaus theorem says is this: BK prime over K prime C times CQ over QA times AP over PB is equal to -1. Again, we are considering the signed length. So if everything goes on the left is positive, it's negative. From right to left, if you move, it's negative. From left to right, if you move, it's positive. Okay? Now, can you tell me, if I draw the 2 pictures in the same place, and if I join QP and move it and put it here at K prime, can you prove using Shiva's and Menelaus theorem that K and K prime are harmonic conjugates with respect to B and C? It's a nifty little theorem. Whatever I have said, you can use that data and give it a shot. Harmonic conjugates have deep connection with projective geometry and many other areas of mathematics, including complex numbers. Maybe in some other video, we can discuss them. I hope you learned something. If you have a question, or if you can solve the challenge problems, put it in the comment section. If you are interested in outstanding Olympiad level mathematics, then you can go to our website, Cheenta.com. We have very beautiful offerings. Thank you for watching. I'll see you in the next one. Bye.